My name is Ignacio Alvarez. You can call me Nacho if you find me in the after party. I'm a senior software development principal for Mercado Libre. I'm part of the platform team. We build the internal development platform for all our company. And I'm technically in charge of the services that we build for our devs. Let's talk about a little bit about Meli, Mercado Libre. If you don't know about it, it's the biggest e-commerce platform in Latin America. It's a lot of things. We have a fintech area, we have logistics, and a marketplace, which is similar to a company you know in the US with a smiley logo. I don't want to name it. It's a huge company, around 100,000 employees, 10,000 engineers, and we run our own platform with a bunch of abstractions that our own devs don't even know about them. For instance, we solve with a simple abstraction, we solve networking, compute, security. Our main focus is make them focus on what they need to build. We also have another abstraction layer, which are these services, in order to get them rid of specifics of a backend. For instance, if they are to use a key value store, they don't have to know about DynamoDB or whatever they want to use. They just use our own service. If they are to use a public subscribe service, instead of using Google PubSub, they just use our own service. This specific abstraction works with our own SDK that goes through a data plane, and then you go to that data plane is the one that knows the specifics of a backend. That gives us the chance to be mostly vendor agnostic and to avoid lock-ins, for instance, for a cloud provider or a specific software product. We also have a big setup, thousands of microservices in 4 major development stacks: Java, Golang, Python, and Node. We are starting to build stuff in Rust. And we tend to grow a lot, between 30% and 60% in infrastructure year over year, every single year. So it's pretty important, this context, because of course, when you build that amount of microservices, caching is key. And when we started thinking of how to build an abstraction layer to get our cache to work, of course, it was a tough process. So the first iteration for our caching solution was pretty straightforward. It was just a solution in which we provision clusters automatically, every single thing that the application owner asked for. They just, at that time, it was a Memcached solution. We just brought up a specific cluster. The size was decided by the application, the amount of stuff they needed to store, and that was it. They used the specific Memcached client and whatever they needed. Of course, that came with major efficiency uses, idle infrastructure, application that had dimension issues, and we didn't have any abstraction or kind of governance over that. But we had some benefits. For instance, isolation from one application to another, and those clusters were exclusive. So what we found out is that we didn't have any kind of governance between for that solution. So we came up with an iteration for this, and it was the second version of our caching solution, which was based on Redis. We kind of rolled it out in 2022. We built the solution from the ground up and did a couple of things differently. The first thing was to do an abstraction with a wrapper SDK in which we have some sort of control, first on the specific SDK we are to use. Second, that gave us the chance to do some hacks in order to be multi-tenant, and it allowed us to have a centralized brain and operate centrally the whole amount of clusters we were to use. We have this control plane that brings up clusters as we used to, but we are now in this iteration, we started being able to be multi-tenant, just adding some prefixes on the keys. The user didn't know about that, but we just were able to share the same cache, the same cluster with different users. The last thing to talk about for this iteration was that our whole company went through a process in which we classified every single application and every single environment based on their criticality for the whole company. So that gave us the chance to be more or less aggressive based on the criticality of the solution. You can be, of course, more aggressive and more cost-effective on the ones that, if they fail, it's not that critical that another one, right? And when you have the most critical system on the company, you choose to be at least a little bit less cost-effective. So then we came up, the Redis thing happened, Valkey came up, we love you, Valkey. And we started seeing a couple of bunch of new optimizations. For instance, we started using Glide. We came up with a cross-platform standard solution. There were some key differences based on the stack, on the specific SDKs. And we brought up a couple of features inside our own SDK. For instance, an opt-in compressions codec in which the user could be able to have those values compressed inside the cache transparently. And a couple of additional efficiency optimizations to be able to scale in and out better and use different types of compute to choose, depending on the moment, to choose different types of infrastructure. One special comment to tell about this is we mostly use managed services. So in this case, nowadays we are using Elastic Cache. We are heavy users for the service. And that's where we are right now. We have 8,000 caches. Half of them are productive, 30,000 nodes. And I want to talk to you about the lessons we learned on this whole path. So the first thing is that multi-tenancy has its caveats, of course. If you are able to control the blast radius, it can be better than if you cannot, because if you share a lot of stuff in the same cluster, if that cluster fails, it can give you a big headache. Of course, when you talk about efficiency and cost efficiency and you want to control what to enhance or what to optimize for or what to improve, this is obvious, or at least sounds obvious. You have many variables to improve for, but in our experience, might be for our workloads, might be for our use case. The bandwidth is a key bottleneck and the one that gave us more headaches. Have a node just dead because of the amount of bytes coming in and out was the most difficult problem to solve. So most of the stuff we did was related to that, was try to reduce payloads, try to give our users the chance to reduce them. And that gave us new ideas for the new iterations. So the next steps, we are starting using serverless solutions. We also are starting to bring up clusters on other cloud providers. Our platform gives us a chance to be multi-cloud. And there's a couple of new things that we are on the works. For instance, client-side caching, or which it's kind of a mixture between an in-memory cache and a distributed cache, in which we are developing a solution that we just store e-tags on the cache, and we store the values, and then we have the source of truth, but we try to avoid, in some use cases, to transfer the whole object to and from the cache. That's on the works. I hope it goes fine. So I hope you enjoyed it. Thanks.